Okay, let's do the evens real quick, and you can check your answers. Try it first on your own and then check your answers here. So the domain is left to right, goes all the way left, all the way right. So that would be negative infinity to positive infinity, right? And that's parentheses because you cannot actually get there. Set notation, it would be all real numbers. Range, it goes all the way down, and all bottom to top, it goes all the way down and all the way up. So it's the same thing for the range. Negative infinity to positive infinity. All right, which is all real numbers. Is that a function? Well, vertical line test, boom, only crosses one time, so yes. Number 4. So we've got this graph, this absolute value graph here. We want the graphs, and it says circle all, that have the same range. So bottom to top, so it goes forever down, right? So that's negative infinity. To the top is right here, so it goes up to 2, right, on the y-axis. So the range is negative infinity, bottom to top, and it does include this point. This point is included, so I'll use the square bracket. So no, so not that one. Nope. Oh, here we go. Negative infinity up to 2. So that works. Negative infinity, yeah, but oh, this goes up forever. Goes up forever. Bottom, and it goes up forever too. So it's just that one. All right, number 6. Okay, so local maxima. All right, so that's a max is the highest point. So that would be, and it says state as ordered pairs. So that would be, let's see, -1, and then up 1, 2, 3, 4, right? -1 and up 4. So -1 and 4. That's going to be my local maximum. X-intercepts, well, I've got 1 here, 1 here, and 1 here. That's on the x-axis. So I'm going to do this as an ordered pair. So that would be -7 with 0 for my y. And then this one would be -1, 2, 3, -3 with 0 for the y coordinate. And then this one is +1 with 0 for the y coordinate. And then zeros, that all you have to do is put the x values. So -7, -3, and 1. Okay, x-intercepts and zeros are the same thing. They're just written differently. All right, and then if I'm going to do my domain here, I'm looking, remember domain is left to right. So it goes all the way to the left, so that would be negative infinity. And it going to the right, here's where it stops, right? And it's an open circle at 5. So that's parentheses. And then range is bottom to top. So the lowest point is over here, and range is always the y values. So it would be -4. And that is a square bracket because it actually does include this point. It's on the graph. And then it goes up, and this goes up forever, right? So it goes to infinity. Constant means horizontal line, so that would be here. So that's from 1 to 1, 2, 3, 4, 1 to 4. All right, so from 1 to 4, and I'm going to use parentheses there. And the interval of increase, let me erase because it's getting pretty messy here. So increasing as I go left to right, So I'm going down the slide. Now I'm going up the slide, right? And then these are my turnaround points, my stationary points. All right. So I'm going to go up to see what that x value is. This is my, when I'm doing the intervals, it is the x values. So that would be -5. And then all the way here is where it stopped increasing, was at -1. All right, so from -5 to -1, all in here, it was going up. I probably should highlight that instead of just coloring it in. All right, but you can see that. So I'm going up here, that's increase. And then it turns around, that's decreasing, constant, decreasing. All right, so that's it for increasing. Now when I'm looking at decreasing, I start on the left and then now I am decreasing, right? I'm going downhill. And it was all the way to the left, so that would be -infinity. Where did it stop decreasing? What's my stationary x value? That's that -5. Because that's what I'm saying up here. That's where it started to increase. So decreasing, boom, that's an interval. Now it's going up, oh, and then now I'm going down, right? Well, what's the x value? -1 to +1. So I'll use my u, and then -1 to +1. All right, and then now I'm going constant, horizontal, and then here is decreasing. So that would be from 4 to 5. So one more. From 4 to 5 was that last little decreasing interval right there. All right, so I've got decreasing here, and decreasing here. So those are my 3 decreasing intervals. Local minimum. So minimum would be a low point, like a valley, right? So this, like the dip. So there's a local minimum. All right, so that would be at -5, -4. Oh, I guess that was supposed to go with my, and so here's the local minimum, local maximum. All right, top of the hill is the max. And then y-intercept is where it crosses. Here's my y-axis. Where does it cross here? Right there. So the y-intercept is going to be when x is 0. What's that y value? 1, 2, 3. It would be 3. All right, so now we want the inverse. So f of x means y, right? So I've got -2x plus 6 all divided by 3. So now you have to do the switcheroo. So switch the domain and the range. So x equals -2y plus 6 all over 3. All right, and then now if I'm solving this, again, you have to do like kind of the farthest away from the y. So I've got this, all this is divided by 3, right? So what I'm going to do is I'm going to multiply both sides by 3. Right? And so that's like 3 over 1, and so that cancels out. And so that gives me 3 times x, and then I've got -2y plus 6. All right, and then, right, farthest away, so the inverse of plus 6 is -6. So I'm going to do -6 on both sides. Can't combine that, right? So I've got 3x minus 6 equals -2y. And then now this is stuck together, so that's times, right? So I'm going to divide by -2. Divide by -2. And that's kind of messy. So I'm going to bring it up here. So that goes away. And so I've got y equals, I'm going to use my symmetric property. I'm going to flip it. And then I've got 3x minus 6 all over -2. All right. And so now if I want to kind of tidy that up, if you don't see that answer, you're going to write, and for the inverse, I'm going to put, instead of y, I'm going to put f to the -1 of x equals, and then now I'm going to kind of divide everything by the -2 here. So that would be -3x over 2. And then here I've got a -6 divided by -2, so that would be plus 3. Alrighty. And that is your final answer. And then now number 10, I am going to put g of x inside f. All right, so that means I'm going to, there's no numbers here, so I can't get a number. I'm going to have all x's. So I'm going to start writing f, and then I'm going to put g of x in it. So if I say I've got f, and then I'm going to put g of x inside my f function. So I start writing my f function, which is 5. But when I get to the x, I'm going to put in g. So I'm going to put in the 2x plus 3. So that's g. Actually, let me make g be blue. And f is going to be red. So let's erase this guy. All right, so f is 5. And then when you get to x, I'm putting g inside, right? This g is going into here because I wanted that to be blue. G is blue. So let's make it blue. So this g is going inside. So 5x, g is going inside that x. And then now I have -6. So I'll continue with f. All right, so 5x minus 6, that's f. But I've got g inside it, okay? And then now what I'm going to do is use my distributive property here. So 5 times 2 is 10x, and then 5 times 3 is 15. And then I've got -6. And so I've got f of g of x equals, oops, I meant to just put it down here, not so, oh well, it's in the middle, 10x, and then 15 minus 6 is a +9. Alrighty. And now for number 12, I'm going to take g and put it in f. All right, so here we go. I'm going to start writing f. So this would be -3, but I'm going to put g in it. All right, so I'm going to put g in, make this a little Christmassy. So here's g, 1/3 x plus 2. And then I'm writing f, so I'm going to put +6. All right, negative 3x plus 6, and I'll put the g inside. All right, g is inside of f. And then now I'm going to use my distributive property. So on Desmos, take negative 3 times 1/3, that would be negative x. All right, that's 1. Negative 3 times 1/3 is 1, and then you've got a negative 1, and then I've got negative 3 times negative 2 is negative 6, and then I've got the plus 6. All right, so negative x is negative x, and minus 6 plus 6 is 0. All right, so I've got f of g of x equals this negative x. And then now I'm going to put f into g. So I start writing out g. I'm going to write, g is my red one, right? So I'm going to write g, so I'll write 1/3. And then when I get to the x, though, I'm going to put in f. So I'm going to put in a negative 3 x plus 6. All right, so I put f, right? The f is in g. And then I have the plus, oh no, I'm writing out g. Oh yeah, so then I have plus 2. Plus 2. It's easy to get lost in what you're doing here. So let me check to make sure I've got it right. So g has f in it. So here's g 1/3 x plus 2. Boom, that's g. And then f is inside of that. Okay, and so now I'm going to use my distributive property. So 1/3 times 3 is 1, and so this would be negative x. And then 1/3 times 6 is going to be positive 2. And then I've got a plus 2. So I've got, this is g of f of x equals, and then that would be negative x, and then I've got 2 plus 2 is 4. So are they the same? No. All right, so I should have, if it's the inverse, you would always get x, all right, a positive x. So they are not. All right, to be inverses, you have to have f of g of x equal to g of f of x, which equals x. All right, so when you do that, you should get x. And this did not happen. All right. So it's not the inverse. And then on 14, I'm going to shift this over. So this means I'm going to go to the right one. So I'm going to take this point and I'm going to move it to the right one. All right, I'm going to move all these points to the right. And I'm also going to move it down one. So let me erase that. All right, this means I'm going to move it to the right one, and this is going to move it down. So I'm going to go to the right and then down. But everything else is the same, all right? It's a translation, so it's the same shape. So to get from this point to this point, you go over and up. So I'll go over and up, right, over, oops, and up. So there's that. And then on this side, you go over one, up one. So over, over, up, over, up, right? That's how you get to all these points. Oops. Oh my goodness. Alrighty. And then 16, you got the domain and range, so -4 to, right, domain is left to right. So yeah, -4 to infinity, that looks good. Range is -2 to +2, but that's just these, right? Those are just the y-intercepts. When you're doing the range, you have to go look at all the way to the bottom and then all the way to the top. So this should be the correct range, right? Should be -infinity, right, for the bottom, up to +infinity, because it goes forever up and down. And then 18, we kind of looked at before. So if I've got f of -4, that means x is -4. Right, so I go over to 1, 2, 3, 4. There's my x value. And what would be the y value? What's the point on the graph? Actually, it's hard to tell. That's actually a little bit over, I would say. It might be, it's kind of like in the middle. Maybe I'm overthinking it. Actually, I'll just make this big. So it's going to be, if x is -4, we'll say y. It kind of looks like it's in the middle. I'm going to say, we'll say -2.5. I might be overthinking that. So if you go 1, 2, 3, 4, go down here, where is it crossed? And then over here to see what the y value is. For 4, this means y equals -5. So the y is -5, 1, 2, 3, 4, 5. And then go over to see what the x value, here's the point, and then the x value would be 2. Okay, is this a function? Yes, it is, because of the vertical line test. Is the inverse a function? No, because of the horizontal test. Awesome. Good job, guys.